Up until this point, we've been talking about all carbon and hydrogens, right? Hydrocarbons that just have carbon and hydrogen, some double bonds, some triple bonds, whatever. But that's not all organic molecules. You can start adding things onto organic molecules and change those molecules and give them different properties. And that's what we're going to see when we start looking at things in the body and all kinds of other molecules. So we are going to expand on these alkane, alkenes, and alkynes with functional groups. So a functional group is when we add things like oxygen, nitrogen, or sulfur to organic molecules. So I will get into naming for all of these different ones as we go along. So these are all basically hydrocarbons, and then we edited them in some way. So what we're going to do for our generic table here with the different functional groups is a capital R represents a carbon group. Okay, or a hydrocarbon group you can kind of think of, because it could be a methane or an ethane or an octane that we put onto these. And I'm just talking about the other part. So like we're ignoring the carbon part for now, but that is what R represents. R is just a general designation for an alkyl group. So anything that's carbons and hydrogens. Okay, so these are the families. So right, alkanes, alkenes, and alkynes are families. These are the different functional groups that give us different families. So there's alcohols, ethers, aldehydes, ketones, carboxylic acids, esters, and amines or amides. And the general formula, remember, R stands for carbon hydrogen group. So this could be, like I said, a methyl or an ethyl or whatever it may be, if it has an OH on it. So if it has an OH somewhere in the molecule, it is an alcohol. So our general formula would be ROH. An example is ethanol. So see how this would be an ethyl group and it has an OH somewhere in that molecule that makes it an alcohol. So this is called ethanol. So we like change the ending. Kind of see there. I'll get more into those later. So alcohols have OHs, and you should be able to identify that and the following. Ethers look like this. They have an R group on one side, an oxygen somewhere in the middle, and an R group on the other side. So ROR. So I have a methyl over here, an oxygen, and then another methyl over here. This is an ether. The way that I was taught to remember ethers is that it's an oxygen with two R groups, and it looks like the ether bunny. So that O in the middle is your ether. Okay. Now, if you have, so I have an OH on one end, I have an O in the middle. Now I'm going to do aldehydes and ketones, which kind of go together. They have what's called a carboxyl group, and that is a carbon double bonded to an oxygen. Okay, so this is specifically a double bonded to an oxygen. Now, if it has an H on the end and not another R group over here, meaning this thing is terminal or at the end of the molecule. So if it's R, C double bond O, H, that is called an aldehyde. Okay, this is an example. I have an R group or a methyl over here, C double bond O with an H. Now, if it is instead of an H, another R group, so R, C double bond O, R, so it's in the middle of a molecule, that is called a ketone. So methyl over here, that's one R group, carbon double bonded to an O, and then a carbon CH3 over here. So this one is a ketone. So if it's on the end, if it ends with an H, it is an aldehyde. If it ends, or if it's in the middle somewhere, it's got carbons on both sides, it is a ketone. All right. And then carboxylic acids have two oxygens. It has a double bonded O and an OH. So this is not considered an alcohol. It has these two things off of one carbon, makes it a carboxylic acid. And yes, they do have acidic properties. That hydrogen can be a little bit acidic. So if you have any R group with a COOH, C double bonded O, OH, that is a carboxylic acid. Okay. Esters are similar, except that you have that C double bonded O somewhere in the middle. Okay. So like aldehydes and ketones, carboxylic acids are on the end, or they are terminal, they end in an H. And esters would be if you have that C double bond O in the middle. So you have an R group on both sides like this. I've got a methyl, C double bond O, and then another methyl over here. That would be an ester. So don't get ethers and esters mixed up. Okay, ester is like a carboxylic acid with a double bond O. And then we have amines or amines, really anything that has a nitrogen in it, for the most part, would be considered an amine. Okay, so I've got nitrogen and then I have R groups on all sides or H's. There's not like a designation between terminal and somewhere in the middle. So if there are R's or H's, it's considered an amine or an amine.